just a lost weather balloon. An Air Force spokesman confirms tonight that this was no flying saucer.
Alright, so this is the full asymmetric small motor. I have to build from scratch the board, as you can see, and it has the two sensors located exactly at 180 degrees from each other, and this has got all four pairs of coils. And I had a this is the winding, kind of a little lousy here, a lot of wires, but they're color coded, and the output are yellow and blue, and white is positive and black is negative. So I built a ring right in the center of wire. That's my ground, where all the blacks are going. However, each sensor pulses only two pairs. So the top pulses 3 and 4, and this one here pulses P1 and P2. So I had externally to set the little capacitors. They are the way they come. They are 2.2 picofarads and 50 volts rated. And it seems like, since there are so much coils right now, this is the winding that goes actually in two of the regular symmetric model. And you can see it right here. It's the comparison. It's very obvious. But the problem I'm having is, since the coils are open constantly and there are more coils, even though I put 4, each little motor has, each original motor had 2 caps, and since I have 4 windings, 4 complete windings, I had to put 4. But it seems like the spikes back, because this is completely open. It's higher, the spikes, and the problem I'm having right now is they saturate with electrical. I just run this motor a little bit, and I'm gonna show that measuring the motor is completely not connected to anything. Oh, and I wanted to point out, I had 2 positives out and 1 negative. The negative, I made it common to both sensors, and there are 2 positive, and the second positive is the one like a second speed, and that's the one that activates the other sensor with the other 2 coils. So these 2 cables are running just half a motor, like in my first video. And when I add this one positive, it kicks all the, and it of course it increases speed, RPMs, and torque. But the problem, like I'm saying, the problem I'm having is that, let me take a quick measure here so you could see it. And that's the meter there, and I want to, it's set for millivolts. What I'm gonna do is just touch the ground and touch all 4 outputs where it is connected, and see, 300 millivolts. That's almost 0.3 volts, and 259. It has dropped down, but when I recently had it running, it was over 300. right here, and I guess the caps are not good because they keep retaining and that's not good because that affects the performance of the motor. This is a pretty important issue here. What I did is the two positives from P1, P2 and P3, P4, I kept them attached, and as you can see I use some glue in here. You don't want this is the beginning of each coil, each pair, so you don't want this to break in because they go all the way in. It'll be impossible. You'll have to rewind your work, a lot of work. So I make sure that I use a little insulation there, and I tip some glue in there, some of this stuff that is like a sand, and you pour it in, and then you put like a type of a crazy glue in it, a little drop, and make sure they come in two, in black and aluminum. Says for aluminum and metal surface, gray plastic surface. This is important because the black one it's electricity conductive. This is not. So this you can pour it inside of even terminals and it won't close or even make any resistance at all. It won't build anything. So this is steady here. It's important. Don't have I add a little slice, a little piece of fine wire, and took the insulation off and just weld it in there. Put the insulation, the heat shrink, and the glue in there. So I have a pretty steady. So when I mount it on the circuit, and also make sure you mark one of the pins. I mark this one, which is P4. I mark it by turning it a few times in the red winding on the base, on the black plastic base. That way I always have a reference. 4, I mark it 4, 4, 3, 2, 1, and I go with the 4 right there, and I know it always, in case I have to take it apart again, which I have done a few times, and they fall right in place. And then these tips I told you from the beginning, from the positive ones, are gonna be right here on this welding, which is gonna be your positive feed. Okay, and so all I have to do is just come with a soldering gun and just touch it, tap it there. And also here, notice that it's right there, right in the spot where the positive is. So I just have to touch it there with a little bit of soldering, and it'll be stick there. All right. Well, I wanted to do this test. This is a brand new one. Just pull it out of the envelope. And this is the other one that we've been working on. These are the two. The two are the symmetrical type, and I'm going to have them both running in parallel. So I connect them red with red and black with black, and I want to watch it, measure RPMs, and see how much how many amps they're drawing together. I want to watch that. So here we go. They're drawing half an amp, 490 milliamps. These are two motors. They're going 1964, 1960, 1959, and this one. This one is factory one, sealed. It's got the brand new grease. The rings are in there, so it's making 2,000 2009, 2013, 15. So that's an increase to put the grease in there, and this one is losing like 30 RPMs because of not having the grease and the lubrication bearings. I'm sorry, the retaining rings and all these little things. So going 47.47 amps, and now and of course the amount of air that they're throwing out is nothing compared to the asymmetrical model. So here's just one fan, but actually it's got the windings of two motors and two ICs. And it's also drawing 39 amp, and it's going 27 20 something. See, it's dropping RPMs, and that's due to I'm pretty sure it's saturation of the caps. They're not supposed to. Well, I'm at 11.5 volts, so let me go 12.1. I'm doing 2784. $13.8. I'm at 3,000 and only 470 milliamps. $13.8 volts. Alright, so that was a demonstration I wanted to do, and yeah, well, if I put grease in it, it's I want to measure now the if they have retained any current, any voltage. So no, they're fine. Yeah. It's working out perfect with this type. Yeah, they're not retaining anything. So it's the rating. Good. Okay, so here we have the test of the 2.2 100 volts test. So gonna be testing it for first with P1, P2, and then all four. Let's measure temperature on the coils. It's 89 degrees, 88, 89, 88. First we're gonna try P1, P2, and let's see both. So it has 22. 65 at 26, 260 milliamps. Now I'm gonna add the other two pairs. It's drawing 43 amps. I'm sorry, 0.43, 430 milliamps. And it's going 2900. And now it's 420 milliamps. Bouncing back and forth in between 42, 43. We got 28, close to 2900 RPMs. It's a lot of air. Now, temperature on the coils. 107. 107. 97. 96. 92 on this one. Running the two above hotter than the other two. So anyways, it's not much. So do it again. $28.80. At 420 milliamps, and very, very steady. disconnect just one. That's P1, P2, 25 milliamps, 2200. Let me check now. This will tell you if the pairs, your pairs, are balanced. More or less, it's be about the same. 2209. That's pretty good. And again, that's the second. That's P3 and P4. These are the two cables together, the black and red, that came originally from the P1, P2 fan. Joining it again. Watch the difference, or hear it. Over 28, 2870, 6970. And gaining. And decreasing to 41, 410 milliamps. That's pretty steady there. One hundred and 22, 97, 98, and 91. For some reason these two above are getting hotter than this one, but it's nothing, it's just warm. These motors are very easy to cool off by opening fins here and letting the air, the same part of the fan will blow into the coils and then perforating the board and perforating back here. It just blows the air and keeps them cool. But you know, they're not hot at all. But whenever they're gonna be working for long periods of time, it is recommended. Alright, thanks for watching, guys.